friends, in first video we have already studied about Euclid division lemma. Now we are going to solve some important applications of Euclid division lemma. Here is the first application. So that every positive even integer is of the form 2m, and that every positive odd integer is of the form 2m plus 1 for some integer m. We have to prove it. Now let's start proving. Proof. Let n be an arbitrary पॉजिटिव इंटीजर. किसी भी तरह के एप्लीकेशंस को आप सॉल्व करेंगे, इसको आपको फर्स्ट ऑफ ऑल सपोज करना पड़ेगा. लेट n follows be an arbitrary positive integer. Now on dividing n by divisor 2. Clear? On dividing n by 2, we have m as quotient and r as remainder. Clear? On dividing n by 2, we have m as quotient and r as remainder. Then by Euclid division lemma, dividend equal to divisor into quotient plus remainder, n equal to 2m plus r, where r is greater than or equal to 0 but less than divisor means 2. This is dividend equal to divisor into quotient plus remainder, or r equal to 0 and 1 because r is less than 2. Case first. When r equal to 0. Clear? When r equal to 0 means remainder is equal to 0. This implies that n equal to 2m. Clear? N equal to 2m, where for some integer m. In this case, you can see n equal to clearly even because m is some integer. If you put at the place of m 1, 2, 3 positive integers, 1, 2, 3, 4, 5, 6 and so on, so we will get multiples of 2. Means in this case n is clearly even. Is there any problem? Now case 2, when remainder is equal to 1. This implies that n is equal to 2m plus 1. Is there any problem? No. In this case n is clearly odd. Why odd? Because m is for some integer m is some integer means positive integer. If you put at the place of m is 1, 2, 3, 4, 5, 6, then first 2 into 1, 2 plus 1, 3 is odd integer, 2 2 is 4, 1 5 is odd integer, 2 3 is 6 and 1 7, totally odd integer. It means in this case n is clearly odd or mister. So after this, here in this case n is clearly odd. Now we can say that Hence, every positive even integer is of the form 2m, and that every positive odd integer is of the form 2m plus 1 for some integer m. इस चीज को आपको क्वेश्चन को यहाँ पे कॉपी पेस्ट कर लेना, ठीक है? Is there any problem? No problem. Now for next, proceed. Now here is the second application of Euclid division lemma, so that every positive integer, not even, not odd, totally combined, so that every positive integer is of the form 3m or 3m plus 1 or 3m plus 2 for some integer n. Now let's prove it. Before it, we have to prove every positive even and every positive odd, but here is the complex, every positive integer. So let n be an arbitrary positive integer. Clear? On dividing n by divisor. What is divisor here? 3, 3, 3. Clear? By 3. We have m as quotient and r as a remainder. Clear? Then by Euclid division lemma, we have dividend equal to divisor into quotient plus remainder. 3m plus r, where r is greater than or equal to 0 but less than divisor means 3, or r equal to either 0, r1 or 2. Clear? Very good. This implies that n equal to 3m or 3m plus 1 or 3m plus 2. Clear? Means when we take remainder is equal to 0, first one is 3m plus 0, second at the place of r is 1, then 3m plus 1, at the place of r is 2, then 3m plus 2. Clear? Now case first. Clear? Case first for this, case second for this, and case third for this. Means here we can say that every positive integers, hence we can say that every positive integer is of the form 3m or 3m plus 1 or 3m plus 2 for some integer m. क्लियर है? तो यहाँ पे आपको क्वेश्चंस को कॉपी पेस्ट कर लेना यहाँ से लेके यहाँ तक. क्लियर है? उसके बाद लिख देना है रूट. क्लियर? नो प्रॉब्लम. So now here is the third application of Euclid division lemma, so that every positive odd integer, only odd integer, every positive odd integer is of the form 4m plus 1 or 4m plus 3 for some integer n. Clear? Only every positive odd integer. Same. Let's start proving. Let n be an arbitrary positive integer. Clear? On dividing n by 4, divisor, here is divisor 4. Clear? On dividing n by 4, we have m as quotient and r as remainder. Clear? On dividing n by 4, we have m as quotient and r as remainder. Then by Euclid division lemma, we have dividend equal to divisor into quotient plus remainder, means n is equal to 4m plus r. Clear? Here r is greater than or equal to 0 but less than 4, or r is equal to 0, second 1, 2 and 3, because r is less than 4. Clear? 0, 1, 2, 3, 4. There are 4 cases here. This implies that n is equal to 4m or 4m plus 1 or 4m plus 2 or 4m plus 3. ये कहाँ से आए? Putting the values of r here. First 0 for 4m, 1 for 4m plus 1, 2 for 4m plus 2 and 3 for 4m plus 3. 4m plus 0, 4m plus 1, 4m plus 2, 4m plus 3. Now here, case. Only we have to show that odd integer is of the form 4m plus 1 and 4m plus 3. Means यहाँ पे दो आपको दिख रहे होंगे 4m and 4m plus 2 जो कि एक्स्ट्रा है, उसको हटाना है. किस तरह से हटाएंगे? केस फर्स्ट. Stop it. So we are here n equal to 4m plus r, where r is greater than or equal to 0 but less than 4. 4 cases are here. 4m, 4m plus 1, 4m plus 2 and 4m plus 3. 0 for 4m and 1 for 4m plus 1 and 2 for 4m plus 2 and 3 for 4m plus 3. Now case first, when r is equal to 0, this implies that n is equal to 4m. In this case, you can see that here m is some integer, m is some integer. If you put some integer 1 to positive integers 1, 2, 3, 4, 5, 6, then we will get the multiples of 4, means these are totally even numbers. Means in this case we can say that n is clearly even. Clear? और हमको क्या चाहिए? Only odd integers. Clear? Case 2, when r is equal to 1, this implies that n equal to 4m plus 1. When n equal to r equal to 1, this implies that n is equal to 4m plus 1. In this case, you can see that 4m is even, but 4m plus 1, it becomes odd. Clear? In this case, we can say that n is clearly odd. Clear? Case third, when r is equal to 2. Clear? In this case, this implies that n is equal to 4m plus 2. Clear? You can see that 4m is completely even, and even plus even is always even. Means in this case, once again, n is clearly even. And now in the last case, case 4, when r is equal to 3, this implies that n is equal to 4m plus 3. Clear? Here 4m is completely even, 4m is completely even, and even plus odd is equal to odd. Clear? Means we can say that hence every positive odd integer, only odd integer, every positive odd integer is of the form 4m plus 1, 4m plus 1 or 4m plus 3 for some integer m. इसको आपको कॉपी पेस्ट करना है यहाँ से लेके यहाँ तक और यहाँ पे पेस्ट करना. क्लियर है? एंड देन रूट.